we're good to go with the levels of solution. There are three types of solutions, and they are, first of all, unsaturated. So I'm going to draw a line right here. So if this was my, hold on, let me make sure I got my pen working. Okay, so if this was my solution and this was the line, and I draw a dot and it's graphed and it's plotted down here, then that one is unsaturated. I'm holding very little solute and as much solvent as possible. That's like a small little teaspoon of sugar in a big glass of iced tea. Okay, our next one is saturated. I'm holding as much solute, could be sugar, at a given temperature. So when plotting that point, it would actually be right on the line. So if you draw and you plot the amount of temperature to the amount of solute on a solubility curve, then if the point falls directly on the line, then it is saturated as well. It is holding as much of that solute, that sugar, at a given temperature. The last one is supersaturated. Supersaturated, as we said, is the most unstable. It is where you're holding more solute than a given more solute than that solution can hold at a very, very, very high temperature. So I got to raise that temperature. So if I were to plot it on the graph, it would fall up here way above it. So if it's above the line, it's supersaturated. On the line, saturated or unsaturated, it would be below the line. All right, now we talked about electricity and electrolytes. So the electrolytes are basically, if I can get my computer right there, okay. So electrolyte in a conductivity tester to show you where I'm going to mix salt and water in there, okay. So when you mix salt, okay, when you mix salt in water and you use that special conductivity tester, you can show that electricity has been formed because a little light will light up. A non-electrolyte solution would be where I add sugar in there. If I add sugar with water, no electricity will actually form. So that would be an example of a non-electrolyte. Okay, concentrated, always think of your orange juice. When you go to the grocery store, they always sell 100% pure concentrate orange juice. And that means that it is 100% orange juice. But if it is a little bit too strong and it really is not good, maybe my stomach, or it irritates my stomach, or it burns, what I can do is I can dilute it. So a diluted solution would be like a watered down. So just adding water to the solution, it will actually water it down. Okay? Our next one are the rates of a solution. So three ways you can actually speed it up. First of all, if I stir it, then that will speed it up. That solute, that sugar, will dissolve in the liquid. Or I can heat it. I can put it, add a heat source to it, and it'll dissolve a lot quicker. Or I can actually powder it, put it in a powder form like granulated sugar. That will dissolve a lot faster than the actual cubes. Okay? Now, let's look at today. We did our solubility curves yesterday, and remember, on these solubility curves, we graphed the different information. We're going to come back later and answer some more questions about the solubility curves. So, let's take a look at acids and bases. Okay, now an acid. As we know, acids burn. Okay, and they're a compound that actually produces hydronium ions. And you might say, well, what is that? So if I look at water, water is H2O. And it is 2 hydrogen atoms and it is 2 oxygen atoms. So in that compound right there that I'm producing that is an acid, I'm basically pulling out the hydrogen that's in there, at least one hydrogen, out of that compound and actually producing a type of compound. And our compounds that are an acid actually begin with the letter H. So if you see HCl, then you know I'm dealing with an acid. Okay. Another thing, it actually can dissolve in water. And as I said, the formulas start with H on there. Now, properties of acids. Now, number one, acids have a sour taste, like lemons. Think of lemons and grapefruit. They're very sour. They're very corrosive. That means that if they're exposed to a metal, they're going to make it break it down, and they're going to eat away at some of the metal. They're going to react violently with the metals, so therefore the react violently with metals and the corrosives kind of go hand in hand. They are an electrolyte. That means that if I put my conductivity tester in an acid, it will light up as well. They're going to burn the skin. So look at these very vivid pictures down here where someone had an acid burn to their hand by not handling it properly. Okay, and the pH scale of an acid is 0 to 6. Okay, 0 being the strongest, 6 being the weakest. And again, as I said, they're going to start with the letter H. Some common acids that we have strong and weak. The strong ones, hydrochloric acid, HCl, sulfuric acid, what Mr. Bill makes or uses at the plant to make phosphoric acid, H2SO4, and nitric acid, using nitrogen in there. It's a nitrate mixed with hydrogen. But some weak ones that we see that we can find from the grocery store. We can find vinegar, which is also called acetic acid, and we can also find boric acid. Boric acid is a very weak acid that actually ophthalmologists and optometrists use in washing out your eye if it's irritated. It's a very cleansing solution, but it is slightly acidic. Some other pictures that you see over here, lemon juice is another example. Alright, so now let's transition to bases. We talked about acids, now let's look at bases. So bases are a compound that produces hydroxide ions. So remember, we took the H from the water, H2O, and we're left with an OH over there. Okay, so bases end or produce an hydroxide ion when dissolved in water, and therefore they're going to end in OH. Okay? So, some basic properties, they're bitter. Think B for base, B for bitter. Look at that poor little girl and her face. She ate something that didn't agree with her, and she's making a very bitter face. Okay, again, they're corrosive, just like acids. Okay, and they're slippery. Think of dishwashing liquids up here. If you put it on your hand, it has a nice slippery feel to it. They dissolve oils and fats. In fact, that's how Dawn got into its heyday. Dissolve the oils that were attached to the feathers and to the fur of animals that were from an oil spill. Okay, and they're an electrolyte as well. And they will cause a burn to the skin, just like the acids. Not quite as severe, but they will. Their pH is from 8 to 14, and they end in OH. Okay? Some common bases that we have, if they're strong. The first one is sodium hydroxide, which is found in your Drano and other items like that. Potassium hydroxide is another one that's found in some of our medicines and laxatives. Magnesium hydroxide is another one. Again, most of your laxatives. But some weak ones that we have are deodorants and ammonia, and also soaps and detergents as well. Okay? So what we have right there is, how do I determine if a compound is an acid or a base? Well, the first thing we do, and remember, acids start with H, and think acids before bases, A before B. So acids start with H, and bases end in OH. Okay? Now, if you have a compound and it is neither an acid nor a base, it doesn't start with an H or end in OH, then we're going to classify that as a salt. Okay? So here we go. You tell me. LiOH. On your paper, write down acid, base, or could it be a salt? Okay, the next one, HCl. What do you think? Acid, base, or salt? The next one, NaCl. What do you think? The next one, NH4OH. And then we have this one, Ca3PO4 in parentheses with the 2 outside. And the last one, H2SO4. What do you think? Okay, now, sometimes if I'm sick and my tummy is a little upset, then sometimes we want to neutralize it. That means my stomach probably is producing a lot of acid. So in order to make yourself feel better, what we'll do is add a laxative, or we'll add maybe a Tums or milk of magnesia. We'll take that. Well, that component is actually a base. So when I add an acid to a base, like we have up here, an acid with a base, then what we produce is a compound that is neutralizing it. So neutralization is a process where an acid and base are chemically combined, and the products that they're going to form is salt and water. Okay, so here's that neutralization reaction. So that's a reaction between acid and base, and our products are salt and water. Because think about it, if we're neutralizing it, neutral is actually on a pH scale 7, and water is usually neutral. This kind of reaction is a double replacement. Okay? And here we have an example. So we have HCl, that's your acid, and NaOH, that's your base, and they're going to produce NaCl, which is table salt, plus water, H2O. Now, our pH scale basically is used to determine whether something is a pH. It has either it's an acid or a base. Okay, and so what we have, our number line usually starts with 0 and works all the way to 14. Okay, so key thing to remember, our acids are down here in the range of 0 to 6. If it is a very strong acid, it's going to be between 0 and 2. Then we have our base. Our base range is over here, and it is 8 to 14. So what we have here is strong bases are 10 to 14. It's a bigger range for those stronger bases. Okay? So water in the middle that we didn't mention, water has a pH of 7, and that's usually pure water. Okay? Pure water. Alright, so we also have these cool indicators that are out there. So how do I know if something is an acid or a base? Well, the first type of indicator we're going to use is litmus paper. And litmus paper is just basically red paper or blue paper. And what you do is you actually dip it into a substance, and you determine whether or not it's an acid or base determined by the color change on the paper. If you put blue litmus paper in an acid, it's basically going to turn red. Okay? If you put it in a base, it's going to stay blue. Red litmus paper. If I put red litmus paper in an acid, it's going to stay red. But if you put red litmus paper in a base, it's going to turn blue. So an easy way to remember this, if it's a base, it will turn blue. Base turns blue. B for base, B for the color blue. Alright, other indicators that we have, of course the easiest one to use is pH paper, and that gives you a more accurate level as to the grade or the rate of what that acid is. Depending on the color, you just match it with the color identified down here, and you can tell what the actual level of the either it being an acid or a base. The other one that's kind of fun is called phenolphthalein. Phenolphthalein. And phenolphthalein is also found, actually, it's found in your X-Lax tablets, not in the chewable ones. But if you take it and you take this liquid and it smells a little bit sweet, and you put it in an acid, it's going to stay clear. But when you put it in a base, it will turn hot pink, that fuchsia color. It's real pretty. Okay? So, just wanted to share with you acids and bases and indicators, how you can determine whether something is an acid or a base. All right. Enjoy.